Yeah, welcome everyone. We are very proud to be here today and to present you one of the many solutions that we've built on top of CloudBolt, which basically presents the core of our hybrid cloud framework. And we will start with the short introduction. Go to the next slide. And just a short agenda for you to know. So I will just give a short introduction about Visorian and why we went this journey and why we choose CloudBolt. And then Christoph will take over and guide you through the solution, the requirements, and how we help the customer with the solution to tackle these requirements. So, right, about Visorian. So first of all, for myself, I will shortly introduce. I'm the CTO at Visorian, Microsoft Azure MVP as well as my colleague. And we're a Hamburg-based cloud consulting company with a focus on customer success. And we were founded with the idea of putting the customer and their project success back into the focus and to deliver quality based on our values. So therefore, we have a team of very highly experienced specialists in cloud technologies who always try to deliver the most modern, but also most suitable solutions to our customers. We're shaped by our four core values: partnership, innovation, quality, and transparency, which guides us through our daily life, our daily work with each other, as well as our customer relations and projects. One of our core competencies is hybrid cloud management. And over time, we figured out that our customers always face the same kind of challenges when introducing or adding new cloud platforms to their infrastructure landscape, which is why we have developed a hybrid cloud management framework to support all the essential core areas and thus avoiding chaos during implementation and also during the adoption phase and for day two processes. Our framework, on the one hand, covers the technical requirements that are reflected by the areas of automation, workload, flexibility, identity and access management, and monitoring that you see on the slide. And on the other hand, we also cover the areas that take care of the requirements resulting from internal processes like the company culture and adoption. And these are reflected by culture, lifecycle management, governance, and cost management in this diagram. After we evaluated various solutions, we chose CloudBolt as the core platform to integrate and implement the requirements defined by these phases, basically. So by the phases of our HCM framework at our customer. So yeah, with this last slide, I would like to hand over to Christoph to show and present the solution that we have integrated based on the flexibility of CloudBolt and that we use to handle advanced customer scenarios that integrates, in this case, into Microsoft Azure and Azure Kubernetes services.
Thank you, Jan-Henrik. Yes, hello, and welcome also from my side. At first, I would like to introduce myself. I am Christoph Burmeister. I am a senior consultant at Visorian, and I'm a Microsoft MVP for Cloud Data Center Management, and I specialize in infrastructure automation, DevOps, as well as identity management. And yeah, now I would like to give you a short introduction of our customer, for whom we made this CloudBolt AKS integration with the company Hamburg Süd. So Hamburg Süd is one of the 10 biggest shipping companies in the world, and it also ranks among the 5 biggest container shipping companies for refrigerated goods. The company was founded in 1871 and is headquartered also here in Hamburg, Germany. They currently employ a little over 6,000 employees, and since 2017 they are part of the Maersk Group, so part of the group that is the biggest container shipping company in the entire world. So Hamburg Süd transports tens of thousands of containers every day all over the world, and this is a logistical challenge and can only be accomplished with great software. So Hamburg Süd employs a lot of software developers. They create container-based applications for their own needs, and these applications need to run somewhere, and that's what Kubernetes is for. But first, let me start with why Hamburg Süd chose CloudBolt to begin with. Hamburg Süd started to look for a hybrid cloud management tool as they started to adopt public cloud services with Azure. And due to IT governance and internal regulations, Hamburg Süd decided to provide their users with a self-service portal in which the users can order and manage all their cloud resources. So these services must be managed from start to end. So the entire lifecycle process must be represented without the need to involve the operations team, unless, of course, there's some kind of incident. So besides this, other requirements for the HCM tool were also a multi-level approval process for resources to be compliant with internal processes like the cost management approval, for example, the entire automation. So in a sense that all parts of the entire resource lifecycle are fully automated. So all manual tasks needed to be eliminated. There needed to be a lot of integrations. So this means all relevant providers must be accessible and manageable from the HCM tool. So like local and public cloud providers, as well as database services. So basically every resource that the Hamburg Süd uses must be manageable from within the tool. And of course, the expandability with the case that, so in case something needs to be integrated that, that is not publicly available, it basically must be possible to integrate this, basically by themselves. So we then went into an evaluation phase, and we compared several hybrid cloud management solutions that are listed in the Gartner Magic Quadrant. And after a few weeks, CloudBolt came out on top as a winner because it offers the most flexibility compared to other solutions. And with CloudBolt, organizations really don't have any restrictions in what processes they want to establish, because the modular approach of CloudBolt makes it very extensible. CloudBolt comes with several integrations out of the box. And if this is not satisfying for any reason, there's always a possibility to build and extend the capabilities of CloudBolt, basically yourself. So it's very, very expandable. There we are. And also, against all odds, CloudBolt was not just the solution that offers the most flexibility of integrations, but it was also the one with the best price. So other competitors offered much less functionality for a way higher price here. And last but not least, we needed to be able to use the latest features of public and private cloud providers. So the release cycle of CloudBolt, there was a big concern here because Hamburg Süd wants to stay on top of cutting edge technologies and adopt trends as they come. And this is really something that's being delivered here. So as we started the project, one of the first questions was, who are the users of Kubernetes, basically? And with this, I do not mean the users that actually that use the applications running on Kubernetes. I mean who uses Kubernetes as a platform, and these are the software developers. So the operations teams, of course, also, but they actually only come in when something is wrong most of the time. And since developers are the main users of Kubernetes as a platform, we geared the entire solution that we designed for Hamburg Süd towards them. So there is currently a Kubernetes distribution in place at Hamburg Süd, but they wanted to take full advantage of all the cloud services because they are adopting more and more cloud services basically every day at this point. And this is why they decided to move all their workloads that are currently running on their own Kubernetes distribution towards AKS. So the managed Kubernetes service from Azure. So Azure is a cloud provider that Hamburg Süd chose a few years back, and it was the only logical decision to choose AKS for their applications, because they're already using a lot of Azure services, and it also didn't bring and it also didn't make any sense to move to another distribution because most of the application deployments were already in place since Kubernetes is already used. So just some smaller adjustments were necessary in this department. The current Kubernetes distribution that Hamburg Süd uses is basically a very static entity that does not meet the requirements anymore. So you see during certain development phases, Hamburg Süd has a very high demand for computing power, but only requires them for a short amount of time. So a static solution doesn't scale at all and is therefore not a valid solution anymore. So AKS offers much more flexibility and is very good when it comes to rapid cluster deployment. And the pay-per-use model makes it much more cost-effective. So the good thing is when it comes to AKS, you only pay the computing power. So basically, you only pay the virtual machines that are being deployed during the cluster deployment, and the management of the Kubernetes service itself is basically for free. Since all developers and the entire IT staff is already using CloudBolt to handle all their IT resources in Azure, it was only logical for us to use CloudBolt to manage all the clusters from CloudBolt as well. Okay, so just in case, if you're not familiar with Kubernetes as a product, I will give you a very quick rundown on what it is and what it's actually used for. So the adoption of container-based applications is rising more and more, and companies start using or increase the usage of container-based applications. And Docker was the first. So Docker was basically the first platform that really streamlined this process and simplified the usage of containers, because the technology itself is by far not new. So and managing these containers by themselves is a very time-consuming task and goes really against the simplification that it is supposed to bring. And therefore, an orchestration is needed for all these containers, and this is where Kubernetes comes in. Kubernetes is by far not the first container orchestrator. Docker has their own take with this, with a solution called Docker Swarm, which is actually being deprecated at this point. But there are also other products like Mesos, for example. But Kubernetes is by far the most adapted orchestrator in the industry. Kubernetes is also often referred to as K8S because the term K8S is just much shorter than Kubernetes. So the 8 in the middle just represents the 8 letters that are between the first and the last of Kubernetes. Yeah, Kubernetes is an open source project from Google. And some of the core features include the grouping of containers and resources to represent an application, and then basically expose everything as one unit or as a service for that matter. Kubernetes allows you to scale the applications. So like you can spawn multiple containers for each application, and the Kubernetes can actually do this based on the performance that is required. But Kubernetes can cannot just scale the application itself, it can also scale the underlying hardware. So which makes it very, very flexible during peak performance demands, for example. Self-healing is one of the core features of Kubernetes. So this means in case one container dies, Kubernetes will just respawn a new one, and the application can basically just keep running. Pods. So why do I mention pods? So at some point you probably heard the word pod or pods in connection with Kubernetes. And what a pod actually is, it's the smallest form of orchestration within Kubernetes, and it's the object that that actually houses the container. So all the computing units are grouped to pods, and this is really one of the core components here. So I just wanted to mention this. Kubernetes itself is available in several distributions. You probably heard about Red Hat OpenShift, which is the offering from Red Hat with some additional features on top of the native Kubernetes product. Yeah, basically. And there are also other distributions like K3s, which is basically just a small version of Kubernetes that's meant to be used for IoT cases and for edge computing. So, but there are several more distributions available of Kubernetes. Yeah. Okay. So with this, now you have a high-level overview of what Kubernetes is and what it's used for. Okay. With all of that in mind, let's have a look at the solution that we have implemented. So in CloudBolt, we created one blueprint for AKS clusters that handles the entire lifecycle process. So, like the order process needed to fit the approval process at Hamburg Süd, because Hamburg Süd has a multi-step approval in place. So we needed some slight adjustment in this department because the approval process differs a little bit from other blueprints that Hamburg Süd has. The order form, apart from some necessary internal governance parameters like application and service owner, the technical input has been reduced to a minimum, so we are able to enforce governance and compliance rules here. So, but I will go into more detail in this during the demo. Since we reduced the amount of technical parameters during the order, this means this has an impact on the entire deployment, and more of the technical decisions need to be made in the background. So the deployment of AKS itself is done with Terraform, and we decided to go here with Terraform because it can also be used for deployments to other public cloud providers as well as private cloud providers. So this is actually a great approach because all infrastructure deployments are handled with one declarative framework. So for this, we wrote a Terraform orchestrator in CloudBolt, which uses Azure storage accounts as a backend to store all the Terraform-related state files. During the deployment itself, some other integrations are done as well, like the onboarding to HashiCorp Vault, for example. So Vault is used as a central secret store in the solution for all the applications, as well as some infrastructure components. So each AKS cluster will be onboarded to Vault, and the cluster can then use a method called sidecar injection, which uses a second container within a pod. So in this container, it can then access secrets that are stored in Vault, for example. So I will not go into too much technical detail here. It's just a quick overview. The integration of DNS was a little bit more difficult because one requirement of Hamburg Süd was to use Kubernetes cluster with a private endpoint. So usually when you deploy a fully managed Kubernetes offering from a public cloud provider like Azure, AWS, or GCP, normally the cloud provider would expose the Kubernetes master API directly to the internet. But due to some security regulations, this was not possible for us to use. But we're actually in luck here because Azure offers a configuration in which the master API does not get exposed into the internet, but rather instead it gets exposed into an internal part of the network that only the customer has access to. So, but with this, some other challenge comes in, because in addition to the private endpoint for the master API, also a private DNS zone is being created, and not all clients can automatically resolve names from this private DNS zone. So for this, we basically implemented a solution based on core DNS that runs on a central DNS server within Azure. So, and if you're interested in this, so I will also not go into too much technical detail here, but if you're interested, you can head over to our blog on itinsights.org, and there you can find an article that's called Azure Hybrid DNS Architecture. So namespaces in Kubernetes are used to separate environments or applications from each other. And for this project, we are so namespaces are basically an essential part and serve basically two purposes. So they are used to assign cluster resources like a CPU and memory by assigning quota limits, as well as assigning permissions to developers so they can actually access the namespaces. And this is done using Azure AD Groups, but I will go into a little bit more detail into this on the next slide. Yeah, lastly, we implemented some other resource actions for cluster upgrading. So like upgrading the Kubernetes the version to basically just newer versions, so the users can take advantage of newer features. And we also implemented a Kubernetes resource overview, which is something that the customer requested because he wanted the developers to be able to have a quick look on all resources that run on the cluster from a central point of view. So we wrote a UI extension for this within CloudBolt, but I will also show this during the demo. So as I mentioned before, we use Azure AD for the identity and access management in AKS. So what Azure Active Directory is it is the Microsoft cloud-based identity and access management service that's mainly used for authenticating against services in Azure and Office 365, but it can also be used by third parties or even your own applications if you try to, or if you want to use this as an identity provider. So this allows us to assign permissions on a group membership basis to specific namespaces, meaning during the creation of a namespace, the user can choose a particular team, and later on this will translate to Azure AD Groups, and then they can, during the membership, they can then access the cluster. Yeah, exactly. So those Azure AD Groups are mapped to roles that are being created during the namespace creation, but I will also show this later on during the demo. Oh. Yeah, which is actually right now. Let me just change my screen share, just a second. So share. Okay, so you should now be able to see my browser window here.
Yep, we can see it.
Oh, thank you for confirming. Okay, so this is our test and demo environment that we use to develop solutions. So let's just head over to the catalog. Here you can see we have, so as mentioned before, we created 2 blueprints during this project. First, the Azure Kubernetes Service blueprint, as well as the Azure AD Group blueprint. Yeah, at first, let's have a look at the Azure Kubernetes Service blueprint. So when the user opens the order form, they need to provide very little input compared to what's actually necessary from a technical point of view to deploy an AKS cluster. The first parameters are only required for internal governance regulations. So like application owner, service owner, project ID, and assigned services are only necessary for internal reporting basically, and for the assigning to different teams. The first parameter that actually has a technical impact is the stage field, because it determines which part of the network the AKS cluster is being deployed to. And this also impacts resources within Azure, like network security groups and the firewall. So resources that handle network traffic based on specific ports. The AKS min and max node count parameter determine how many worker nodes the cluster will actually have after the deployment, and what the number of cluster nodes is that the cluster can scale to. So this means there are virtual machines that actually do the heavy lifting. So, and the number of virtual machines that a cluster will have, I can adjust them here. So the min value represents the virtual machine count that is always being available within the cluster, and the max count describes the number of virtual machines that the cluster can scale to. So based on the current demand of resources on the cluster. So basically all providers, all clusters that we create here are being enabled for auto scale. So the next field is the Kubernetes version. So when you look at Kubernetes as a product, it comes of course in different versions, and as soon as a new version is released, Microsoft takes this version and and updates the Azure Kubernetes service, so then the user can take advantage of all the new features. So this is why we created this value from an orchestration action directly from the Azure APIs. So there's no need for the basically there's no need for the CloudBolt operations team to update a list manually, because it gets retrieved every time we open this field here. And lastly, the node size. What we choose here is the size of the servers that are being provisioned. So all the servers that run later on in the cluster will have the same size. So let's just order a server real quick, a cluster. Assigned services, run lab sounds good. Take a medium one. So, and as soon as I ordered this, what would happen in production? The approval process would kick in, since I'm in my test environment here and I'm logged in as a CloudBolt admin. The approval process is actually skipped, but normally the approval process would of course take place. So this entire deployment will take around 7 to 15 minutes, depending on the number of nodes that we provision. But for the sake of time, I already provisioned a cluster that we can use in advance. So since we also created a new resource type for AKS clusters, we can just use the resource view here, basically up here, and we can then select our AKS clusters, and then we can get an overview on all the clusters that I have access to as a user. So this is the one that is already provisioned. So from here, basically from here on out, this is the central administrative pane that the developers can use to interact with their AKS clusters. So they can directly see what the status is, what all the properties are. They can check the status of the resources that run on AKS, but I will go into this in a second. And of course, all the resource actions. Okay, so let's just start with a quick overview. So they see, of course, the owner, the group that the cluster is assigned to, when it was installed, the rate. The rate actually comes from the service pane. So as I mentioned before, AKS is built based on the VMs that it runs, and we actually combined all the virtual machines with the cluster object, so that we can then directly show the actual rate that this cluster would cost. We then have some information about the Kubernetes internal network structure. So information like the Docker bridge, as well as the pod CIDR and service CIDR. I will not go into too much detail what this is, but yeah, it's here, and it's important for the developer to know. We have the address from the AKS master API. So this value is actually very important because it's required to access the cluster. And yeah, then we have some more information about in which resource group within Azure all the resources are, in which virtual network the cluster is assigned to. We can see the current Kubernetes version, as well as the node size, and all the information that we provided during the deployment, like who's the application owner, what is the assigned services, and all that. Then, of course, we have all the resource actions. So the developer can decommission the cluster using the delete function. We can perform maintenance tasks on the cluster. We can change the max node count. We can upgrade the Kubernetes version, all the namespace related tasks, and of course, getting the kube config. So what this is, I will go into this in a second. At first, I wanted to show you the UI extension that we built. So if you're familiar with the CloudBolt as well as Kubernetes, you probably have already seen that on the top right-hand corner here, we have several new tabs available. And what these tabs do is they show the current status of certain Kubernetes objects. So these Kubernetes objects are, for example, daemon sets, their deployments, namespaces, pods. Basically, we predefined with the customer which resources they needed to see at any time within CloudBolt, and then we wrote the UI extension for this. So, and actually, what happens is, as soon as you click on a cluster from this, so from the AKS cluster resource overview pane, for example, what happens is the UI extension triggers a script which queries all the information directly from the Kubernetes master API for this particular cluster. So all the information that you see here are pretty much live. So it's live from the point, basically, so until I hit the refresh button again. So, and this makes it very, very easy for the developers to see perhaps what is wrong with the cluster, why is application not spawning and stuff like that. So they can basically see everything in regards to this particular object. So, and to show you that this actually works, I will create a new namespace using the resource action create namespace. And when the user opens this, they at first get two informational parameters. So they can see the total amount of milli-CPU resources of the cluster. So these values are created from the server objects that are being linked to the Kubernetes cluster resource. And the same goes for the cluster memory. The user can then specify the quota that they want to set on the cluster. And then they can, of course, specify the name. And so the last part here is they choose a team that later on has access to. So as I mentioned before, we have several Active Directory groups for accessing the cluster. And each team has three kinds of permissions that they get. So they can basically choose from namespace administrators, namespace developers, and namespace readers. So and those three rules roles will be assigned during the creation of this namespace, and they will get then linked to certain Azure AD groups. So I will show you the management of the Azure AD groups in just a second. At first, let us create this new namespace. So what now happens is this will just spawn a new job, and then okay, that namespace already existed, of course. Let's just call it this. So what now happens is Terraform will be creating the new namespace based on the template that we used during the deployment. So, and this job takes normally around 20 to 30 seconds, something around that. And then the new resource group will be, the new namespace will be available. Yeah. As you can see, it ran successfully. And now we should be able to see the new namespace here. Of course, I need to refresh the page first because these values will only be retrieved during a reload. As you can see, I just created the namespace web23. I can also see the time that it's was created, so August 11th, 2020. All the times are in UTC. So you can see that it was created just now. We can also see the quota value that we assigned, and what's really cool is we can also see which team has access to this particular namespace. As you can see, we also have two other namespaces. We have CB test, and the team 1 has access, and we have also test web, and also team 1 has access. So with this, this basically concludes the UI extension. We have some other resource actions for, as I mentioned before, we can change the max node count. So the AKS max node count can be changed later on, because it can be possible for the developer to scale the cluster a little bit higher when the demand grows. We can also change, or we can upgrade the Kubernetes versions. So the same goes here, like the order form. So on the order form, we retrieved all the Kubernetes versions that are available in Azure directly from the Azure APIs. And with the upgrade Kubernetes version, yeah, we did basically the same thing. But there's a slight restriction here. Kubernetes cannot be upgraded in two minor versions ahead. So basically, you cannot upgrade a version that's currently running on, for example, one version 1.16.13. So like this here currently. This is okay. So this is the current version that the AKS cluster is running on in terms of Kubernetes version. And if we want to upgrade this, for example, to 1.18.4, for example, we would need actually to run 2 circles because we cannot directly upgrade to a higher minor version that the current one we have +1. Okay. Anyway, lastly, the user needed to be able to get the kube config. So what a kube config is, it's basically a YAML file that contains all the information about the cluster in terms of how to access it. And this includes, for example, the URI of the master API, as well as some certificate information, as well as the information of the oh my God, authentication method. Jesus Christ. So for the user, basically to access the cluster, they need the kube config, and the kube config file can be retrieved via email using this action here. And it's noteworthy at this point that the user can only access namespaces on the cluster, so not the entire cluster itself. And therefore, they need there is the need for the user to have a namespace that that has an ID group configured in which they're a member of. So, and for Hamburg Süd to be able to manage these group memberships themselves, we created a second resource type. So we called this one the Azure AD Groups. And when we go here, we can see all the Azure Active Directory groups that are currently available for managing access to AKS clusters. So what we did is we just created a new namespace called for the team 2. So let me just filter real quick for team 2. And if I want to access the namespace that we just created, I need to be a member of one of these 3 groups. So for example, I can now just go into this group object. Then I will get, of course, also some metadata information. But what I wanted to be is, I want to be a member of this group. And currently this group is empty. And we also provided 2 resource actions for the Azure ID groups, so the user can basically add and remove themselves. So, so in a production environment, there's of course also an approval process in place that everything can be compliant with the regulations. So what I can do now is I can add myself here. I'm going to run this job. As you can see, the Azure AD Graph API is very quick. And when I hit refresh now, I can now see that I am a member of this group. So, and with this in place, I can get the kube config for the cluster, and then I can access the namespace web 2.3 that we just created. And that basically concludes my demo for this. Yeah, so I hope you enjoyed it. I hope you you get a sense of what we did here for Hamburg Süd as a customer. And yeah, thank you for your time. And I'm pretty sure you have some questions.
Hey,
Thank you.
Christoph. So first of all, yeah, thank you so much. I think this is really amazing to kind of walk through the journey and also see the demo that you showed. I know that Hamburg Süd is a big customer for you. So thanks for sharing all of this. There are a couple of questions that I can see, and the first question is, when you were showing the demo, I could see that a user can select large, medium, or small clusters, right?
Yes.
Is it possible to kind of hide, if I'm an intern, can large and medium be hidden so that by default I can only see the small size?
So you mean depending on the group, for example? Yeah, that would be possible.
Okay, so
That can be arranged.
Okay, so do you use like something like a role-based access control or something like that? Assign them to.
So in this environment here, so those are actually static values, but for Hamburg Süd, we of course also created those values from an orchestration action. So and we pull the information so directly from Azure with yeah, so basically with a much broader yeah, so there are actually much more choices there. So the production environment. So currently here we only have some static values that we use to showcases, but this can be adjusted, of course, and also based on group memberships, for example.
Okay. The second question that we saw was, and I think, are you using Terraform instead of Kubernetes API for configuring the clusters? I think John Hendrik is answering that, but what's your take on that?
Yes, so we use Terraform to deploy the cluster. We use Terraform to deploy some basic applications on the cluster. So for example, we can see here the Vault agent that is being deployed for the sidecar injection. We deploy a separate ingress controller based on Nginx. And this is all done with Terraform. So and also all the actions that you see here on the side. So like changing the node count, upgrading the Kubernetes version. So all of this uses Terraform in the background.
Right. I can also say that, yeah, basically everything that is read from Azure. So for example, the different Kubernetes version for the upgrade action, that is of course taken from the API. So we always choose like the most efficient way and the fastest way. And all the changes like Christoph mentioned are done with Terraform. So they are all reflected in the Terraform state. And every change will be also have a life cycle or as life cycle managed by Terraform itself. Yes.
Yep. So I think the follow-up question that I can see in the Q&A panel is this so that you don't have you don't need the kube config to list nodes or get pod information?
Well, so when it comes to accessing the cluster, there are actually two ways generally. So you can create secret objects within the Kubernetes, but that's a very static way to access a cluster, because this configuration can get passed around, and so later on you don't really know who's using it, and so basically the audit trail is totally lost. And so since we're using Azure Active Directory, each user has their own regular user account, which is then used to access the cluster. And so with this, the entire identity management cycle is being fulfilled.
Right. Also for integration from CloudBolt itself into Azure or into Kubernetes, it's not needed to use the kubeconfig because it's managed inside of Terraform with a specific service principal, etc. And I've also seen that there is another question about if we are working on a way to deploy pods and daemon sets, etc. So we actually have done that for another container orchestrator already, and this is also something that's on our roadmap for the future. So yes. To, for example, create deployments directly from the CloudBolt UI, and also to do some more advanced management tasks like receive logs from containers. So things that you would normally do in like the Kubernetes UI, for example. So some things that can be done or that should be done in CloudBolt will be done in CloudBolt. So we are planning on expanding this feature. That is correct. On the other hand, you always have to be sure that you don't introduce too much operational overhead. So all the features that are faster implemented by the developers themselves, if they have direct access to the cluster, will be done by them. So we also aim to keep the dynamic process of DevOps so that the developers are able to develop in an agile way and are not like stopped or slowed down by using these processes. So our main aim with CloudBolt is always to give an additional benefit to the services that are there and to add like a layer for things like approvals, compliance things, and governance requirements. So as soon as a developer has access to a specific cluster, it's often more better for the developer and more agile to let the developer do these things themselves, so that like I said, as soon as they have access, they can use things like Octant, for example, to do some management tasks and so on. And often it doesn't make sense to replicate like all the features that you would be able to do with kubectl, for example. So it depends on your requirements in your company, but in general, we will expand this feature to have more and more features, and our customers can decide which they want to use and which features should only be used by the developers.
Awesome. Yeah, that was the last question. From my personal sense, I think I learned a lot in this, and I personally feel that looking at the integration of AKS with Terraform and CloudBolt, that was really eye-opening. So that kind of shows the value of all the tools that you're using. So thanks for showing this. So again, thank you so much, Jan Henrik and Christoph, for jumping on this webinar and showing us what you're doing for your esteemed customer, Hamburg Süd. This was really good. And hopefully we'll have you on sometime soon to talk about more use cases. And thank you attendees also for taking the time out of your busy schedule and joining us, and hope you got the value out of this webinar as well. So thank you so much.